Hello students, welcome to Infinity Learn NEET channel. This is Suresh, Faculty of Chemistry from Infinity Learn. Today we are going to discuss about the most amazing topic, dipole moment. This particular topic, dipole moment, is very important for NEET examination. Directly from chemical bonding, you may expect to get one question, and also this dipole moment has an importance in the organic as well as inorganic questionnaire. So let's begin. What is a dipole moment? Let's talk about a heteroatomic molecule, let's say hydrogen chloride. Hydrogen is bonded covalently with chlorine. So there is a mutual sharing of electron. There is a electron pair being shared between these two molecules. Because of the more electronegativity of this chlorine as compared to hydrogen, this electron is slightly migrated towards the chlorine, so that chlorine is going to get partially negative charge and hydrogen is going to get a partial positive charge. So this molecule, now it is getting a polar, one negative pole and a positive pole. There are two poles are being formed because of the moment of the bond. So that we can say a dipole, two poles are there due to bond movement. That is what you can say a dipole moment. So this dipole moment decides various factors in the properties of the molecule. So let's talk about what is actual definition of the dipole moment. So it is the product of the one of the charge on this dipole and the distance between these two atoms. So that is what you call it as a dipole moment. This dipole moment is given as mu is equal to charge on the one pole multiplied with distance between these two charges. So this is the mathematical version of the dipole moment. So the charge can be calculated on the basis of ESU and the distance could be in the centimeters. So it could be in the ESU centimeters and is also said to be D by. So D in the range of angstrom units 10 power minus 8 centimeters and charge in the range of 10 power minus 10 ESU. And 1 d by is equal to 1 into 10 power minus 8 ESU centimeters. So this is the basic version of this dipole moment. Let us look into the application of the dipole moment, where dipole moment of the molecular structure. If a molecule is said to be a polar and a non-polar is decided based on this dipole moment. If the dipole moment is 0, resultant dipole moment is 0, so the molecule do not have any bond moment, so it is said to be non-polar. Similarly, if the dipole moment resultant is not equal to 0, it is said to be a polar molecule. So the polar molecule almost nearly behaves like an ionic compound. And when the molecule is taken, just we have seen the hydrogen chloride, the resultant dipole moment hydrogen and the chlorine. So the bond is moving towards a more electronegative atom, so that is indicated by a tail cut arrow mark. So that is the implementation of the dipole moment. If the dipole moment resultant is not equal to 0, it is polar. Dipole moment resultant is equal to 0, that is said to be non-polar. Moving forward, let us talk about the polyatomic molecule. Let's say a polyatomic molecule, A central atom is bonded to B, and between these two, let us say the bond movement is going to be mu1, and A is bonded to C and its bond movement is mu2, and A and B are separated by bond angle called theta. So the resultant dipole moment could be given as resultant dipole moment is equal to root over nu1 square plus nu2 square plus 2 nu1 nu2 cos theta. Dipole moment is a vector quantity, so that we can apply the concept of vectors over here. So as theta increases, dipole moment decreases. As theta increases, dipole moment decreases, and when theta is equal to 180, dipole moment resultant is going to be 0. As theta decreases, dipole moment is going to be increased. So let's see various examples. The dipole moment of water is 1.84. How it is? Oxygen and a hydrogen and a hydrogen, and the bond angle is going to be 104. When oxygen and hydrogen is bonded, oxygen is more electronegative, so the bond movement with respect to this is like this. Hydrogen and oxygen is more electronegative, so that resultant dipole moment for this water molecule is going to be like this. This is what we call resultant dipole moment of the water. Similarly, you can see in the carbon dioxide, it is a linear structure. In this linear structure, C double bond O. So carbon and oxygen, the dipole moment towards the oxygen, because oxygen is more electronegative than carbon, and oxygen is more electronegative than carbon. So two dipoles are in the opposite direction with the same magnitude. Resultant dipole moment for this is going to be cancelled, it becomes 0. Simply apply vector concept so that you can do the best in this dipole moment. Moving towards BF3 and CH4 and CCl4, the symmetrical molecule always do have the resultant dipole moment as 0. Like we can see BF3 molecule, it is a planar trigonal geometry, so it is a BF3 molecule. And boron and fluorine is more electronegative, so that 3 bond movements are get cancelled because of the 120 degrees angle, so the resultant dipole moment is equal to 0. You can check the CH4, it is tetrahedral. In the tetrahedral, all 4 bonds are going to be cancelled like this. Carbon to hydrogen, carbon to hydrogen, carbon to hydrogen. Carbon is more electronegative than hydrogen, so the resultant dipole moment is going to be 0. Similarly, CCl4 also gives the same geometrical structure as it is CH4. So let's talk about the CCl4. In this case, the chlorine is more electronegative. Chlorine and chlorine and chlorine and chlorine. So in this way, the chlorine is going to pull the electrons out. So the resultant dipole moment is going to be 0. Let us talk about what about the other structure like SnCl2 or SO2. You can take one more example. Sulfur dioxide, sulfur and double bond O and oxygen. So the oxygen is more electronegative than sulfur. As a result of this, it comes like this dipole moment in this way. So the resultant dipole moment is not equal to 0. So like that, the bond is polar and non-polar is decided on the basis of the resultant dipole moment. If the resultant dipole moment is 0, this is said to be non-polar. If the resultant dipole moment is not equal to 0, is said to be non-polar, right? So let's talk about compare the dipole moments of NHE3 and NF3. In the NHE3 and NF3, nitrogen, hydrogen, 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 and it is a lone pair. So the hydrogen and nitrogen is more electronegative, therefore the bond movement is in this way, bond movement in this way, and bond movement in this way. And the lone pair also has a lone pair movement. You can say the direction of the bond movement and the lone pair movement. The lone pair movement is added with the bond movement. So there is an addition in the movement of the electron flow. Whereas NF3, nitrogen and fluorine is more electronegative than nitrogen, so that the bond movement between nitrogen and fluorine is coming outward as compared to the lone pair movement of this NF3. So there is an opposition in the movement of the electron flow. That's the reason why you can check the resultant dipole moment of this ammonia is 1.47, resultant dipole moment of the NF3 is 0.24. I want to say here dipole moment of course NHE3 is greater than dipole moment of NF3. This is very important point as far as the NCERT based NEET type of questions you can expect it here. And also you can say dipole moment in the case of cis and trans isomers. Let us talk about dichloroethene cis isomer. The chlorine and the carbon bond moments are in the same side, so that you can say two bond moments are in the same side, resultant dipole moment is not equal to 0. This molecule has some polarity, so this molecule is said to be polar. Whereas in the case of trans isomer, in this case of trans isomer, you can check it, this chlorine and carbon bond moment is opposing to this carbon and chlorine bond moment. So when they opposes in the opposite directions, and it is going to cancel it, it is going to be 0, it is said to be non-polar. So in the organic chemistry also, this dipole moment is extremely connected, so that you can decide their behavior, and the polarity and the physical and the chemical properties are based on this dipole moment. And also percentage of ionic character can be calculated based on dipole moment and the difference in the electronegativity. It's a simple trick I just want to give you, to give the percentage of ionic character can be calculated taking the observed dipole moment upon theoretical dipole moment into 100. So what is observed dipole moment? That is experimentally identified. What is the theoretical? That what we expect, you can calculate it. So I can say experimental dipole moment upon calculated dipole moment into 100. So based on that, you can expect a question in the NEET examination on the NCERT based. You can see a question. A bond length of hydrogen chloride is 1.1275 angstrom units, and the charge conversion is given here, and if the dipole moment that is experimentally observed, it is 1.02 dBi, and then HCl is various options are given. So let us directly calculate the percentage of ionic character. When you calculate the percentage of ionic character, that is experimental dipole moment upon calculated dipole moment into 100. In that, it is 1.03 is equal to 1.03 into 10 power minus 18 ESC centimeter, and bond distance is going to be 1.275 into 10 power minus 8 centimeter. If we just substitute here, we are going to get 17% ionic character. But when you check this, none of the option indicates the percentage of ionic character. Rather, if it is 17% ionic character, it is going to be 100 minus 17, that is going to be 83% covalent character is coming. So that 83% is going to be the answer. Like that, you can crack questions from the NCERT based NEET examination questions from this topic. And hope you enjoyed today's class. Please like and share and subscribe. Thank you very much. Thank you.